Now I'm going to talk about how I killed my new welder. Shouldn't have happened, but it did. I've been doing that kind of little weld, bashing together the bicycle to just have a first thing to ride. I thought I could just get it out really quickly and then assemble it and go for a ride. And I got the suspension pieces working, and I started working on the steering parts and all of that, but I have this new TIG welder and it's a black day. It won't weld. I did something to the welder to make it so that it won't work. So what I'm doing today is I'm going to finish and clean all this stuff out of the way. Start a new video here in just a bit to talk about the welder and what's wrong with the welder. The welder is from AHP. It's a AHP TIG 201XD. Runs on 110 or 220 volts. It's got a fair number of features. It runs AC, it runs DC. And it worked fine for me. I hadn't TIG welded before, but was able to learn how to do TIG welding, and I think I did something that it wasn't prepared to deal with. So when I was welding, I had accidentally dipped the TIG rod, something you're not supposed to do, but I got steel on the end of the rod, molten steel, and to finish the little bit of a weld, I drew the arc back and let myself have a really long arc and really long plasma. And in TIG welding, that's controlling the voltage. And the next time I went to use it, it didn't work. I could turn it on and use the pedal, and I could see that the gas flow would start, but what I couldn't see was any arc initiation. There was no high frequency start, no nothing, and the thing was just dead. So couldn't weld, couldn't do anything, tried all sorts of things. I checked my grounds, I did continuity tests and stuff like that, and no joy. So the welder's on, I'm set on TIG welding, DC, the 2T control, and this doesn't matter. And basically I'm set for 80 amps on the foot pedal. So I've been welding at about 80 amps for all of the stuff I've been doing. If you look really close right here, when I press the pedal, the gas goes on, and then it goes for its post-weld delay, and then the gas turns back off. So there's a 5-second delay, and then down it goes. But what you'll also see is, if I go here, right, there's no high frequency start, there's no nothing, and it's not doing an arc initiation. You don't see any of the arcing from the high frequency start, and you also don't get any scratch start kind of start. So essentially I'm pretty sure that the power circuits, there's trouble with that. I contacted AHP, and they asked me some questions about, was I AC, DC, etc., etc. They were good. Sent them an email, got a reply. I sent it last night, got a reply first thing this morning. They asked some basic questions, and then they asked some follow-up questions, and now they'd like me to disassemble. But they basically wanted to know, was I running it at 110 or 220? I'm running it at 110. They wanted to know how many amps the circuit I was on, and it's a 20 amp circuit off a generator. They wanted to know how many amps I was welding at. What else did they want to know? What sort of tungsten I was using. They wanted to know, I can't remember what all they wanted to know, but they asked basic questions about how I was using it. Was I able to see the high frequency start, etc. So I described to them what I described to you. AHP has now asked me, would I open up the welder and just make sure all the connections are tight? What I'm going to do is just take the welder out of the welding bench, put it on the table, and open up the case and do what AHP asked, and we'll see what happens. Okay. So this guy's going on. All right, so what AHP said to do was open the case. They said 7 screws on the sides. I see them 1, 2, 3, 4, 5, 6, 7, and 3 up through the back bezels to get around the power cord. And that now shows me the guts. What's remarkable to me is how open it is. That explains why it doesn't weigh 1,000 pounds. AHP asked me to just check electrical connectors. And I'm doing that, and I don't see anything loose. Actually, looks pretty good. I don't see any loose connectors, any parts off, anything like that. It's time to contact them again. Cristian, I'm outside with the unit. I'm not getting the high frequency start, and I'm not getting an arc. And if I scratch it to try and do a scratch start, I got nothing. It's not like I turned a switch accidentally and I turned it off. It was more like it just went from working to dead. I had dipped the rod, the tungsten. The last time I used it, I dipped the tungsten and I drew it back, and I ended up with a long arc length, 3/8 of an inch. I don't know how many volts that represents, but it's hotter than you normally would go, right? I don't have blue tungsten. I have essentially, I think everything I have is thoriated, or I'm now digging in my little supplies. I have some lanthanated, 2% lanthanated. I'd have to reset my collet, and I have thoriated. Yeah, I'm running it off a generator. It's a very clean generator. It's an inverter generator. Yeah, it's an inverter generator, and it is, and I'm looking at it. It's got a 20 amp circuit on it. I'm looking. It's called a 2600. Oh, here I got a 2800. I got a 2800 watts. Right, and I didn't get an over temp indicator light at all. I still have the case off the unit. So Cristian, I'm here. I'm looking at your AHF board. I checked all the connectors, and it really looks clean. Now, let me spin this around a bit and look from the other side. Yeah, right, there's no guarantee. I can put a multimeter somewhere if you want me to do that. Okay, so my ground clamp, I welded a lug onto a steel plate, and I was welding from the steel plate. I had continuity. And I would think I'd at least see the high frequency start, right? Because I have continuity on an ohm meter. And I can see that the gas is turning on and off, and there's no HF start, and there's no arc, and even trying to scratch an arc, I'm not getting it. AC, yeah, I tried all the different permutations and things. I was like, because I was mostly looking to see if I had done something weird with settings. And then I did a little research online, and then I tried to replicate some of what other people did. Right, and running on a generator, you just want to limit how many amps you're welding at. So keep it on the low side. So 80 amps should be okay on a 20 amps. I was welding with it. It was working fine. I turned it off. I went back to it later. I went to turn it on, and I just got nothing. It didn't stop working. I turned it off. Right. Let the fans cool it back down. Yeah, I think for me the question is what will get me back in business as quickly as I can, because I was in the middle of doing something and I got it. So you've got a pin for each of one of those capacitors. I'll do the test this HF board. I'll run the test and we'll figure out how to get the unit right. And after that, I want to just get from you as much as I can about how to run the thing in a way that won't hurt it. Okay. All right. Let me see how I do. It might be tomorrow morning. All right, Cristian, thanks a lot. Bye-bye. I have from AHP this HF board test guide, and they say set this up with 2T, stick, DC, no pulse, and locate X9 at the back of the top board, measure the red and black wires. Readout should be 150 volts AC. I think I'm supposed to do this while this thing's running. They want a measurement here on H9, they want 150 volts AC. And then they want a DC voltage, 500 volts DC on X12. We want 300 volts DC here. X13, great. And then I need X10. All right, those are my measures. Power's on. $323 volts. Let's go around to the other side. So what did I find when I did the high frequency board test from the guide that I got from AHP Welding Systems? They were looking for 150 volts AC on that connector, and I was actually only reading 80 volts. Don't know what that means, I'll let them know. The next connector they wanted to look at was down on the the high frequency board itself, and they were looking for 300 volts on their X12 connector. So we got 323. Then the next one they wanted to look at was the X13 connector. That's kind of tucked in the board and hard to get a meter on. So I followed the other end of the wires, and where it goes to is the ground lug and to the power lug. So one was positive, one was negative. And I looked at that and it was 0 volts. It wasn't giving me any voltage output, which kind of matches with what I'm seeing. And since they had this thing on stick welding, I should have been seeing voltage there. Just to make sure, I went to the generator itself, and I, with the system turned on, measured the voltage AC, and I had 122 volts AC, and I turned the system on and I had the same 122 volts AC. So I wasn't getting any voltage drop on my, or no voltage droop on the generator. So with that, I'll go send them some more information. It's a little more diagnostics than I cared to do with a machine running with multiple hundreds of volts in it, but with some care I could get a meter in there. Now we'll see what happens next. I've traded emails with the people at AHP, and they gave me these 2 more test guides. This one is the driver board test guide, and this one claims to be a test of the AC/DC output. So seems a lot to be digging around inside this welder like this, but we'll go give it a shot. Here we go. We'll go ahead and email them again with all these results and see what they have to say. It's a good thing I have friends in the neighborhood with welders, so I can go and quick make the 6 more welds I have before I can go do the next thing on my project. And in the meantime, we'll see what AHP does. I'll note that it's a little bit weird for their service department to be asking people to open up the case and to touch circuits and things around the high-powered electronics. I don't quite understand that, but that's what they asked, and I'm comfortable enough with that I could do it and could do it carefully. I would suspect that many people shouldn't really be digging into that kind of thing. There we have it. Here's the box. Open it up. They gave me a new manual. It's nice. All right, it has been a week since I discovered the welder wasn't working. In that time, I did my own diagnostic. I contacted the manufacturer. They did a bunch of tests with me, some of which I think were just basic tests and some of which were kind of weird opening the unit tests. How much of those they do with everybody, I don't know. How much of those were just because I was curious, what had I done wrong, or had I done anything wrong? We took it apart, we looked at it. In the end, it was just dead and they couldn't figure out why it died, etc. But they did say, set it on back. Now, a week later, it's back in the bench. I did a basic test on the stick mode to see that it had output voltage. I put it back in TIG mode. I just struck an arc to see that it was striking an arc. Why the old one failed, I don't know. What I did ask was kind of some best practices things. The one thing I'll say is the quick way to figure out is that welder working or is a welder working is to check the output voltage on the main terminals in AC mode. If you don't have that, you probably don't have anything on a TIG welder. They did have recommendations. They talked about, if you can, you want to run on 220. 220 is way better than 120 volt stuff. The comment, if you're running on 120 volts, is a welder's bigger than a toaster. Thought that was pretty funny from the customer service guy. That a normal 110 or 120 volt home plug isn't really good enough. You need a pretty big breaker and pretty good outlet. Other things I learned. Inverter welders are much more sensitive to power supplies than transformer welders. They're more energy efficient, they have more controls, they're smarter, lots of advantage in inverter welders, but they want lots of good clean power. So wall plugs, or if you're using a generator, an inverter generator with extra capacity is a really good idea. The other thing is, when you're done welding, give them a while to cool down before you turn them off. Kind of makes sense. He said they really can hold heat inside for a long, long time if you turn the fans off before it's cooled down. And that's the basic stuff. They gave a table about power coming off the breakers and how much welding amperage you could use. So they said that when you have a 240 volt 2-pole 40 amp breaker, you can run at the capacity of the machine. When you get down to 120 volts, my generator runs on gives me a 20 amp breaker, and then 120 volts 20 amp breaker should limit me to about 90 amps. I was generally welding around 80 amps, so shouldn't have been a problem, but it's an interesting note. And then the thing they say is that if you're running on a generator, you should go a lot easier on the duty cycle, a lot easier on the amps. I don't know that I did anything wrong. As far as I can tell, I didn't. Something just happened to the welder. Broke. They were good. They replaced it quickly. If I had been outside the 30-day window, I would have had to wait for it to be repaired. The bad news is I would have had to wait for it to be repaired. The good news is they probably could have told me more about what had happened to the welder and maybe helped me avoid it a bit. I'm back in business. I would love to hear comments and questions about this, because I just don't really know how to advise people to use these machines better or to use it better myself. I'm a little nervous that at some point this thing might break on me again, but in theory, I didn't do anything wrong, and in theory, this thing should just let me get back to welding, and I'll do that soon. So anyhow, thanks for watching. Any questions or comments are appreciated. One follow-up on the welding. The guys at AHP had an idea that it's pretty tough on any inverter welder to run on 110 volt power, and that the machines are pretty sensitive to what kind of power you give them. So following up on what they suggested, I decided to do this, which was increase the capability of my generator. So this guy is a 5,000 running watt champion welded. Hopefully that'll do some good. We'll find out.